What if the very tools designed to push humanity forward also hold the keys to its undoing? What if the quest for open knowledge and democratized power inadvertently opens a Pandora's box that humanity isn't ready for? These aren't just philosophical questions for a late-night chat. They are at the very heart of the most intense, contentious, and critically important debate raging across the tech world right now. The future of AI. Specifically, our position on open weights models. And nowhere has this debate been more fervent, more opinionated, and more insightful than on Hacker News, where a recent top story ignited a firestorm of discussion that we simply couldn't ignore. This isn't just about code. It's about control, innovation, safety, and the very trajectory of artificial intelligence itself. Today, we're diving deep into this controversy, exploring the arguments, dissecting the Hacker News discourse, and ultimately, laying out our considered position on why this matters more than ever. So, let's start with the basics. What exactly are open weights models? Think of an AI model, especially a large language model like ChatGPT or Google's Gemini, as a highly complex brain. This brain learns from vast amounts of data, and in doing so, it develops billions, sometimes trillions, of internal parameters or weights. These weights are essentially the learned knowledge and connections that allow the AI to perform its tasks. Whether it's writing code, generating text, or analyzing data. For most frontier AI models developed by major tech companies, these weights are closely guarded secrets, kept proprietary, making them closed weights models. You can use their API, but you can't see or modify their core brain. Open weights models, on the other hand, are exactly what they sound like. AI models where these core parameters, these weights, are made publicly accessible. Anyone can download them, inspect them, run them on their own hardware, fine-tune them, and even modify them. Notable examples include Meta's Llama series and models from companies like Mistral AI. This distinction, seemingly technical, carries monumental implications. It's the difference between using a powerful tool built and maintained by a single entity, and having the blueprint for that tool, allowing you to build, customize, and even improve it yourself. The Hacker News discussion we're referencing, which soared to the top of their front page, wasn't just about a new model release. It was a profound clash of ideologies. On one side, you had the proponents of openness, championing democratization, rapid innovation, and transparency. On the other, staunch advocates for caution, warning of existential risks, misuse, and the potential for unleashing dangerously powerful AI without adequate safeguards. It highlighted the raw tension between accelerating progress and ensuring safety, a tension that will define the coming decades of AI development. Let's break down the compelling arguments for why opening up these models is seen as not just beneficial, but crucial for the future of AI. First and foremost is the concept of democratization. Historically, cutting-edge AI research has been concentrated within a handful of well-funded corporations and elite academic institutions. Open weights models shatter that barrier. They allow smaller startups, independent researchers, and even hobbyists to access and build upon state-of-the-art technology without needing billions in compute resources to train a model from scratch. This levels the playing field, fostering a more diverse and inclusive AI ecosystem, preventing a monopoly of power and knowledge in the hands of a few. Closely linked to democratization is innovation. When weights are open, the community can iterate at an unprecedented pace. Thousands of developers globally can experiment, find novel applications, fine-tune models for niche tasks, and contribute improvements. This collective intelligence often outperforms closed Centralized development. We've seen this phenomenon repeatedly in the open source software movement. From Linux to countless programming languages and tools. Open weights could catalyze an AI Cambrian explosion, leading to breakthroughs we can't even imagine from a closed system. Then there's asterisk transparency and research. For AI to be truly beneficial and ethical, we need to understand how it works. Closed models are often black boxes, making it difficult to audit for biases, understand their decision-making processes, or even pinpoint vulnerabilities. Open weights models, by their very nature, invite scrutiny. Researchers can dive into the inner workings, develop better interpretability tools, detect and mitigate biases, and ensure the models align with human values. This transparency is critical for developing trustworthy and ethical AI systems. Finally, the argument for asterisk security through community review asterisk cannot be overstated. Often referred to as Linus's law, given enough eyeballs, all bugs are shallow. This principle suggests that the more people who can examine a system, the faster and more effectively security flaws and vulnerabilities will be identified and patched. If an open weights model has a dangerous flaw or an exploit, a global community of experts can quickly detect and address it, potentially making open systems more resilient in the long run than closed ones, where flaws might remain undiscovered until exploited by a malicious actor. However, the counterarguments are equally potent and deeply unsettling, fueling the fears expressed vehemently on Hacker News and beyond. The most significant concern revolves around asterisk safety and misuse. As AI models become increasingly powerful, capable of reasoning, planning, and even generating sophisticated disinformation, the potential for harm escalates. If frontier AI models, approaching or exceeding human intelligence in certain domains, were to be openly available, the fear is that bad actors, rogue states, terrorists, or even highly skilled individuals, could adapt them for malicious purposes. Imagine advanced tools for creating bioweapons,